today I'm going to be talking about the enterprise use of generative AI. And we obviously know they need guardrails. Specifically in this talk, I'm going to dig deep into how we can practically build guardrails for enterprise applications. My name is Shreya Rajpal. I am the founder of Guardrails AI and also the creator and maintainer of the popular open source library around the same name. Awesome. So why do we need guardrails to start out with? For any of you who have built applications with large language models, you would know that they are fantastic, they are amazing at general purpose reasoning, but they are extremely brittle. Common issues that pop up as we are all working with generative AI systems are that the large language model application that you build out works in prototyping, but it's flaky in running in production. So you would run the application in testing like 5 or 10 or 50 different times, but the moment you put it in production and you scale it out, there are no guarantees that it is going to work as you expect it to. Getting correct outputs from large language models always is hard. Some common issues that we see are around hallucinations, falsehoods, lack of correct structure on an output, etc. The thing that makes all of this very interesting is that the only tool that is available to developers is the prompt. So if you're familiar with working with large language models, what you would see is prompt engineering is all the rage, and how people tend to control LLM outputs is by adding very strict instructions in the prompt. Like if you generate my output so that it is maybe making falsehoods, very bad things will happen, all caps, exclamations, etc. And that's what prompts often end up looking like. Because of all of this, the practical application of LLMs in enterprise use cases where there's serious risk to the large language model not performing well is limited. So anytime where correctness is critical, and correctness is a very overloaded term here, large language models have not been deployed to the scale that we would like to see it. All of this kind of boils down to the problem of controlling LLMs. And this talk basically is about how we can control LLMs in an effective manner. So there are 3 ways or 3 strategies that people have about how we can make this happen. The first is controlling the LLM with prompts. This is the most common strategy that is out there, but there are many issues with this. The first is that LLMs are fundamentally stochastic. So the same input does not guarantee that you're going to see the same output. So even for the same prompt, no matter how much prompt engineering you do, you're not guaranteed to get the same result. And as I said, prompts don't offer guarantees. LLMs will not follow instructions, especially when you're solving more complex tasks, or when the instructions end up conflicting with either user input or some data that you're feeding to the LLM, etc. The second alternative is controlling the LLM by tuning or tweaking the model itself. First of all, this is very expensive and time-consuming. My background and my entire career has been in training deep learning models to a very high degree of scale and to make them very performant, and it's a pretty challenging task. You need custom data, you need to maintain the data, you need to scale out distributed training, you need to do evaluation, you need to serve, and all of this is pretty challenging. Secondly, if you're not training or fine-tuning your own custom model, then LLMs are typically hidden behind an API. So this is a model that you have no control over in terms of the data that you train it on, or its versioning, updates, etc., are outside of your control. The third way, and this is the way that we recommend in Guardrails AI, is combining the LLM with output verification systems. And this means adding application-specific checks and verification programs that ensure that the LLM output is correct. And I understand that this is a mouthful, and so what I'm going to do in a sec is dig deeper into that and talk through what this means practically. All right, so this is the typical workflow of building an LLM application. You would ordinarily have some application logic, and somewhere within that application logic, you would have the LLM module. And what that workflow looks like is that you have a prompt. Typically, all of the engineering effort around this goes into prompt engineering. The prompt is then fed to the LLM. You end up getting some raw output from the LLM, and then that output is fed back to the application logic. What we recommend in Guardrails is a slightly different way of building this, where, of course, you have the LLM module where there's a prompt, LLM API, and then raw output. But that raw output then feeds into a separate verification suite. That verification suite lives outside of the LLM logic, and this typically would contain your business logic. So how the verification suite works is that it is comprised of a set of small, independently executable verification systems or verification programs that enforce correctness criteria or guarantees on your LLMs. So I have some examples here that give you an idea of what this may look like. So you might want to make sure that any LLM output does not contain PII or private identifying information, does not contain profanity. If you are building a commercial application, you want to make sure that any LLM application does not mention competitors, where competitors are going to be specific to your organization. If you are generating code, for example, generating SQL from natural language queries, you'd want to make sure that the code is actually executable in your runtime and in your environment. Let's say you have a totally different task of summarization. You'd want to make sure that the summaries are truthful to the original source text. All of these are small independent programs that you can attach as part of your verification suite and then run as a post-processing step on top of your LLMs. The interesting thing about this is that since each of them work independently, each of them have like a pass or fail signal, and combined together, you can define policies that pass or fail your entire verification logic. If you pass validation, you continue onwards. You pass that output back to your application logic, and everything is great. If you fail verification, the really unique opportunity that has been unlocked with LLMs is their ability to self-heal or to correct themselves if you give them enough context. So if you have the budget for this, either in terms of tokens or in terms of latency, what you can do is add context about which validations failed, why they failed, send it back to the LLM as a prompt, and then regenerate an output that often ends up being more correct than your previous one. Pass it back through your verification logic, and you can continue doing this until your budget expires. So what does Guardrails AI offer you if you're working in this framework? Guardrails AI is a fully open source library that first and foremost is a framework for creating custom validators. So each of the validators that I showed you on the previous page are custom validators that can be created with Guardrails. It is the orchestration of prompting to verification to reprompting implemented for you, so you don't have to orchestrate the whole thing yourself. It is a library and a catalog of many commonly used validators across multiple use cases. And finally, it is a specification language for communicating your requirements to LLMs that is more robust and defensible than just the prompt. All right, so this was set up. What I'm going to do is kind of ground this whole discussion in the example of getting correct SQL. So let's say this is the use case that someone may have where you're building an application that takes a natural language question over some data. And given that natural language question, you generate SQL queries. For example, what was my spending on my account over the last month? And for the purposes of this example, the database that we'll be operating over is a department management database. So it contains, what departments there are, how many employees there are, etc. All right, so we're back to our application logic from before, where we have the LLM module and the secondary verification logic verification suite. Except the thing to note here is that what programs you're verifying are now different. I hope people in the back can see it, but if not, the new tests that we have in your verification suite are A, that SQL is executable for your runtime. B, that there are no private tables. So if there's any private data in that database, you're not exposing that to your end user. And C, there are no risky predicates. So even if the user wants to, let's say, delete your data, etc., you make sure that you don't generate like a drop SQL query and execute that in your runtime before verification. So with that, we're going to go through what the workflow or what the execution framework of working with an LLM looks like. Let's say this natural language query comes in of which department has the most number of employees. With this, we first construct a prompt. So this is an actual use case that Guardrails AI supports with all of this implemented for you. So what you can do is hook it up to a database of examples of previous queries on their natural language counterparts. And the prompt will automatically be constructed that contains the most relevant similar queries that have come to this in the past. So the prompt will contain like first similar queries, second, the entire schema of your database, and then finally, what is the actual question that a user is asking from you. For this prompt, we end up getting this raw response from the large language model. And for the purposes of this demo, this is kind of like a contrived example where, let's say this query is wrong because the table departments doesn't actually exist in your database. Again, this is a very simple toy example, but for more complex implementations like these errors can be much more complex. What Guardrails AI does is when you run this through the verification suite, we'll see that no private tables passes, no risky predicates passes, but your SQL is not executable in your database, once again, because of the lack of, because of the table name being incorrect. So now this is where the magic happens, where Guardrails AI automatically recreates a prompt for you with all of the context about which validations failed and why they failed. So for example, again, there's a toy example, but the re-ask prompt, which is automatically constructed for you, will have, okay, this query failed because table departments is not found in the actual database, and then more helpful context to let the LLM correct itself. When we send this prompt back to, so this is the reconstruct prompt step. This prompt is then sent over back to the LLM API, and we end up getting this response of the raw output, where we see that now the table name is corrected to department. When we run this through our verification suite, we see that all 3 tests pass, and so we continue this on outwards to our application logic and maybe show some visualizations, etc., whatever the user might need. So here's some examples of validations that either are in the library or like custom, very specific, business case specific validations that you can create with the library. So I'm going to take a second here to let you guys read through it while I sip my water. But essentially the idea here is that like ground level stuff, like JSON structure, my query should be structured in a specific way, or my query, my LLM response should have specific types, etc. All of that is implemented. But also this can get pretty complex. Like if I'm translating text, make sure that my translated text is high quality. And this is implemented by internal machine learning models that check for this, that check for the translation quality, that don't rely on the LLM itself. If you're summarizing text, make sure that the summary is faithful to the original text. It's not hallucinated. And each point, each sentence in the summary can be attributed to some specific source. Let's say you're building an application for a healthcare chatbot. Make sure that there is no healthcare advice in the text that is generated, because that can open you up to liability and to lawsuits, etc. Let's say you're building a customer support bot, you can make sure that there are no private questions that you don't want to ask your customer, etc. So in the talk up until now, I've only talked about re-asking as the way to handle validation failures. And re-asking is pretty powerful, and it is a net new capability that large language models unlock. But there's a lot of other ways of handling validation failures that Guardrails offers you. For example, being able to programmatically fix the output if you're working in an application or a use case where that's possible. Being able to filter very, very specific instances of the validation failing. So for example, in the case of summarization, if the rest of your summary is good, but there's one sentence that is hallucinated, you don't need to throw out the entire summary. You can only filter out the offending sentence. Sometimes your response may be bad enough where you want to refrain from answering if enough risks are associated with that response. This is one of the most interesting ones for me, because this is essentially do nothing. Like there's no cost of running the validation, but like any validation that fails gets logged. And so this is a very rich data source of all of your runtime, requests, their responses, and for your application, like what was the criteria that is good for those requests and what is the criteria that's bad. And that is a very rich data source that you can use for either training your own models later or building better prompts, etc. And finally, raising an exception. So I'm going to give a quick demo of this live. So I'm putting a lot of faith in the Wi-Fi here. But we talked about text to SQL, and I'm going to show what this looks like in practice. Again, this is fully open source. I'm demonstrating something that is available to you today. So to set up, what you need to do is instantiate the text to SQL module in Guardrails, either with your schema file of the database that you have, or with the connection string to the database. And I do this here, and I also connected with a repository of examples of like past queries, etc. So for example, these are what my past historical queries look like, how many heads of departments are older than 56, and the corresponding SQL query for that. So given this information, here's my schema file, here's my examples. I initialize the text to SQL module. And then I run this query, what is the name of the department with the highest number of employees? This is doing all of that verification, validation, re-asking, etc. under the hood. And I hope my internet doesn't disappoint me, and it didn't. So this is a query that we end up getting back. So this obscures a lot of detail. So I'm going to, once again, create this like contrived toy example of what happens when you deliberately create an incorrect response. So let's say I change the name of the department table to departments. So I mostly want to demonstrate what the re-asking flow and verification flow looks like. Cool. When I pass this incorrect query to my LLM module, it will once again run validations and re-asking, etc., run the query, and this is the response that you end up getting back, where we see that the table name is now corrected. If I actually look at the LLM output, I can see that the first query failed validation, and it generated like a rich kind of like context about why that failure happened. And this is obviously going to be very, very, very application specific. So let's say if your summary is not similar enough, it will contain like all of the context about the summary instead of this. This is the new prompt that is then constructed automatically with like all of the helpful examples of why that query is incorrect. We run that prompt from the to the LLM and then get this response, which then passes validation. And you can customize this with like prompts or other examples that you want to add, etc. All right, getting back to my slide deck. In summary, Guardrails AI, fully open source library that is a framework for creating custom validators, the whole orchestration workflow of prompting, verification, reprompting, many commonly used validators across multiple use cases implemented for you, and a specification language for communicating requirements to LLMs. To follow along, you can check out the GitHub package at shreya.r/guardrails. You can check out the docs at getguardrails.ai, or you can follow me on Twitter at ShreyaR or at guardrails_AI, where I talk about this constantly. Thank you very much.